freecoachingtoday.com.
So we all of us know that g, the value of the acceleration due to gravity, is 9.8 meter per second square. So how can we actually measure and arrive at this result using some simple applications, simple experiments? We will use some simple cameras, and I hope you will find it fun to do it yourself as well. Before we go do that, let's go to the theory of it. The theory says that the distance covered in kinematics by a particle s is given by u multiplied by t plus half gt square. So basically, let's say if a particle is falling from a height, this is a mass m, some mass m, it doesn't matter what the mass is. If it's falling from a height towards due to the earth's gravity, and if it's released with an initial speed t, and it falls all the way to the ground, and let's say it takes time t, and the distance is covered in this duration is s, then s is given by u, initial velocity, multiplied by the time it takes to fall, plus half gt square. Let's say initial speed u is equal to 0. In that case, s becomes 0 into t plus half gt square is equal to half gt square. Now from this we can find out g equal to 2 into s divided by t square. It's easy to measure s. We just need to know how high is this point from which we are releasing a ball to ground. Now with t is it's a bit difficult to measure, but what we'll do is we'll use a camera to record the falling of a ball and then find out the initial and the final time and find the difference. So once we measure s and once we measure t, we can calculate the value of g. Let's do this experiment now.
Okay, so we took a video of this ball falling from the height of my fridge all the way to the ground. And then once I have taken this video, I use Windows Movie Maker, imported it on my computer. And one of the good things that Microsoft's Windows Movie Maker, or for that matter any video application software does is, it has a time display for each of those frames. So once you play this movie, you see that this ball falls all the way from the top. Now what I do is I bring it back to the point where it's just at the start of the fall. So I'm going back and at the same time looking at this time figure, and I'm trying to find out the start time. And this start time is it's very close to, let's say at this point it starts just falling down, and this time is 1.94 seconds. And the next time I try to do is the moment it tries to hit the ground, so I move it slowly and as I go down, and that's the point that where it's just going to hit it, and I record this point as 2.52. Now from 1.94 to 2.52, we can find out the time it takes for the ball to fall from its height to the ground. The next thing we will need to do is measure the height of this refrigerator. It's just an inch above my height, which is 5.5 feet and 5 inch. So it's about 5 feet 6 inch, and which in meters converts to 1.67 meters. So I take these three data and put it up in my Excel sheet. And so here is my Excel sheet that records the distance of the refrigerator, height of the refrigerator, it's 1.67 meters. And then this is the start time, 1.94 seconds, and this is the stop time, it's 2.52 seconds. And then we can calculate the value of G as 2S, S is on in this G4, divided by T square, which is the difference in the time, G6 minus G5 into G6 minus G5, both in the denominator. And once I do that, I get the value of G as 9.92 meter per second square. So in this experiment, this is slightly higher than the actual value of G, which is about 9.79 meter per second square. We could potentially increase the accuracy of this result by exactly measuring this height using a ball which is dense and which does not rotate. This time I slightly slide it, but it also rotates, so it has some initial rotational energy. We could also record this video using the newer phones that records at 120 frame per second instead of 30 frame per second. What it will do is the adjacent frames will be more clearer. In this way, the ball is falling down, so it's a little blurry, and you don't know where the exact points are. But no matter what, it gives you an idea of how to use a simple experiment to calculate the value of G. Hope it's going to be fun for you as well. Thank you for looking.